you very much, everyone, for being here. And yeah, as we can see during this session, we are going to see how to manage Kubernetes workloads using operators, so using the so-called operator pattern. And next. Just a little bit of introduction. I am Paolo. I am an engineer who works at Red Hat on the Kafka team, so mostly working on Kafka and how to run in Kafka on Kubernetes. And I am also a Strimzi maintainer, and as we will see later, Strimzi is one of the projects as part of CNCF for running Kafka on Kubernetes. I am also a CNCF ambassador. But yeah, the most important part about me is that I am a Formula 1 and MotoGP addicted. I am one of those crazy guys waking up at 4 a.m. in the morning to watch the races. And with me, there is Kate.
Hi, my name is Kate Stanley. I'm a principal software engineer at Red Hat. So I work in the same team as Paolo on Kafka running on Kubernetes. I'm also a Java champion, a LinkedIn Learning presenter, and as of October last year, an author. So if you're interested in picking up a book, then stick around till the end and we'll tell you how to do that. So today we're going to be talking about Kubernetes. So I'm just going to do a quick show of hands. Who is using Kubernetes in some form? Most people? Cool. And has anyone heard of a Kubernetes operator before? Yeah, quite a few. And is anybody using a Kubernetes operator? OK, not too many. So today we're going to talk about what an operator is and hopefully give you some insights so that you can understand whether you might want to use one, whether you might want to build one. So we obviously are all familiar with Kubernetes in this room. So it's a system for automating deployment and scaling and management of containerized applications. And we like to think of it as a Linux kernel, but for distributed systems. Gives us a bunch of different features: container scheduling, automated rollout rollback, horizontal scaling, service discovery. But when we're talking about Kubernetes operators, the main thing we need to remember is Kubernetes is declarative. So you define your YAML file. So here we've got a pod, our basic building block in Kubernetes. And the Kubernetes cluster will make sure that whatever you've requested, it will take the correct actions to make that happen. So in this case, it's a pod running a few containers that make up our application. So we're going to immediately dive in a little bit under the covers and see what this looks like. So in Kubernetes, we have our API server. This is where we make all of our requests for what we want to run. So we can do this using the REST API, but in general, people use the kubectl CLI instead. And we can basically call it and say, this is the YAML file that I would like, and Kubernetes will make it happen. So it's using etcd for storage, but the key thing here is the scheduler down the bottom. So that's responsible for determining where to schedule the pods on the underlying infrastructure in Kubernetes. So we've got pods and we've got containers, but our applications don't make up one pod and one container. This is probably a better representation of all of the containers that you will need for your entire system. So we've got containers and pods everywhere. But how on earth does Kubernetes help us handle this scaling and rollout and batch execution and so on? And it doesn't do it with just this single pod YAML. So as well as the pod, there are lots of other kinds of resources. You've probably seen many of these. So we have things like replica sets, deployments, and stateful sets that determine a certain number of pods. And then we've got things for determining the underlying infrastructure, config maps and secrets for configuring and storing secrets. We've got other things like services for networking. So Kubernetes provides all of these different types of resources that you can use in order to tell it what you're actually after. But how does that work? It works with a controller. Not this kind of controller, but we'll look at specifically what the controllers do. So controller is used for anything that is managing those numbers of pods. So it's things like deployments, stateful sets, and replica sets. So let's look specifically at how does this work. We have, within Kubernetes, a controller manager that is running one or more controllers. So the controllers are containerized applications, And they are sitting and talking to our API server, and they're responsible for the declarative aspect of those resources. So all of the controllers are running what's called a reconcile loop. They first observe, so they watch for resources that have been created or resources that have been updated. Then they analyze. So here they're analyzing the resource, but also what's already running on the Kubernetes cluster. They look at the desired state and then make sure that that's reflected. So that's that key thing around what's the difference between what we're expecting and what's actually there. And then they act. So they determine what are the steps that I need to take to get to the eventual state that the user has asked for. So we're going to take this a bit more specific and look at an example. But first you need to consider, how does the controller interact with the API server? So for observe, it's doing a watch. So this is going to be told every time a resource is updated or changed or created. It's then using get and list to actually list what's happening in the cluster and then create and patch. So let's look at replica set as an example. So when you create a replica set, the controller is watching, and it observes replica set has been created, I need to do something. The next step is, of course, analyze. So it will look at the specification, and in this case, we've got 2 replicas, and we can see what is the container that we're supposed to be running in our pods. And at the moment, we don't have any pods or containers running in the system. So for act, it knows, OK, well, I'll just create 2 new pods. And then you can see the container is the right image there. So this is fairly straightforward and hopefully something you're all fairly familiar with. But what happens if the spec changes? What happens if somebody scales? So in our replica set, we've currently got 2 replicas, and we've got our 2 pods running. If I update this to 3, then, of course, because the controller is watching, it will get notified something's changed. OK, I can see there's now 3 replicas. At this point, the controller doesn't just go, OK, I've got 3 replicas that I need. I'm going to create 3 pods. It's got to do that analyzing of what's already in the cluster. And it does this using labels. So we have our selector in our replica set that says, I want to match these labels. And then in the pods, we have the matching labels. So it can check and see, OK, I've already got 2 pods that are part of my replica set. I'll add a 3rd one. So that's all, again, fairly straightforward. But what happens if you've got existing resources in your cluster, and then you create a new resource which is at a higher level? So here we've got 2 existing pods. Somebody's created these manually. And then somebody else comes in and says, actually, I'm going to create a replica set. So the replica set controller, again, says, OK, I can see I've got to do something. I'm going to analyze. But here it will find that it's got 2 existing pods that are already the correct labels. It doesn't matter that these were already there before the replica set was created. From the controller's point of view, they match, so they're part of this replica set. So what it will do is it will do 2 things. It will effectively take ownership of those pods, and any time now the spec changes, it will apply those changes to these pods. But it also will create the new pod because we've asked for 3 replicas. So you can see here that beyond the role of the controller in terms of taking your resource and making the correct actions, you also need to consider what happens if I create these higher level resources. And specifically, if you're wanting to create a replica set, you shouldn't be changing these pods. If you made changes to the pods, the replica set controller will just come in and put them back to what it was expecting. So is it really that simple? That's just taking the spec and then applying it. Well, let's look at what happens when we take this a level higher above replica sets. What happens if we want to add additional behavior beyond just creating other YAML files? So we talked about replica sets here, but let's talk about deployments. So in a deployment, we have the specification where we've got, say, 2 replicas, and then you've got something called a strategy. So this is the default, which is a rolling update. When I create this deployment, the deployment controller will actually see this and say, OK, in order to create the 2 pods that you want as part of your deployment, I'm going to make use of a replica set. So the deployment controller will actually just create the replica set, and then the replica set controller will come in and create those 2 pods. But the interesting thing here is the additional behavior you get when you change something. So let's say I've decided I've got a new version of my container image, I want to update it, and so I update my deployment to say I'm going to move to version 2. At this point, the controller doesn't just go straight away and update that replica set. Instead, what it does is it actually creates a new replica set with the new configuration. And initially, you can see that it's only got 1 replica. So now we've got 3 pods running, but 1 of them has the new configuration, and then 2 have the old ones. And then what the deployment will do is it will actually gradually scale up and then scale down the new and old replica sets until eventually all of the pods that are running with the new configuration. So what we can see here is that the controller is not only creating specific YAML files, but it's actually doing a very careful act of creating multiple different YAMLs and carefully deciding which ones should be changed when you do an update. So it's that additional step beyond just creating something. It's what's that behavior that I'm going to provide. So what have we learned? The first thing you need to remember going into the rest of this talk is a user manages the highest level YAML. So if you're using a replica set, you don't touch the pods. If you're using a deployment, then you don't touch the replica set or the pods. The second one is we have controllers that are responsible for creating those lower level YAML files, and they run through this reconcile loop. So they're observing, analyzing, and then taking the necessary steps.
OK, thanks, Kate. So let's move to the next step now. Now, we have all the kind of Kubernetes constructs in order to run our own containerized application, right? So we can use a deployment in order to deploy our own application in a container. We have our config map in order to make some configuration on the application and things like that. But it's in general not always that simple, right? You can think about complex application where by complex application, I mean something like a database system or a messaging system. And we will take a messaging system as an example later. If you think this kind of software, they run in kind of a cluster mode, so you have different nodes. It's not that simple to configure each node and then doing some configuration change, enrolling the nodes, and then upgrading the version and things like that. So it's not just about, OK, I have one deployment, I have the config map, I can just change the deployment to have a new version of the application, or I can just change the config map to have the new configuration for my application, and so on. You can, of course, think about this application needing more YAMLs, more Kubernetes resources. So pods, multiple config maps, secrets, or network policies, or storage for PVCs and things like that. And you can think of a human operator going and creating all these YAMLs on the Kubernetes cluster in order to deploy the application. But then he has also to take care of all these YAMLs, all these resources in order to configure, make some configuration changes, upgrading, securing the entire application. So what if we want to kind of make everything simpler and automate all these kind of steps? So we are moving from the pod, from the pod to things like deployment and stateful set and replica set, so to a higher level. So let's move on to a more one step, to a more higher level. So this is where the operator pattern comes into the picture. So let's think this way. What if we want to make our, let's say, complex application as a kind of first-class citizens in our Kubernetes cluster? So we know that in Kubernetes, we have the API server, which exposes different endpoints, the endpoints for the pods, for deployments, and replica set, and deployment, etc. And we have the controllers watching at these endpoints in order to get update and to apply changes. But our complex application is not known by Kubernetes, right? So we can extend the API server by using the so-called custom resource definition. So the custom resource definition is itself a Kubernetes resource, and that's a way for extending the API server. In this example, we are creating a custom resource definition defining a new kind. So as Kubernetes knows the kind pod, the kind deployment, etc., it starts to understand what a kind complex app is. And the CRD also describes the spec for this custom resource, so that you can define all the configuration, all the information that you need to deploy your complex application within the corresponding custom resource. So it means that when you create this CRD with all the definition of your custom resource as a schema, as an OpenAPI schema, then the user has the opportunity to just create a custom resource describing your complex application. So the user doesn't deal with deployment, pods, and all the other stuff. He's just able to describe my complex application, so providing the metadata, the spec, and the status, where the status will be, so will be updated later by Kubernetes in order to provide you what's the status of your application to be deployed. But the user is just using the tooling that we know. So he can interact with the HTTP endpoint directly on the API server, or maybe using the kubectl tool, as we do every day, in order to create this YAML. Now, so at this point, just with the CRD, we are avoiding the error by the API server to say, hey, I don't know about complex app. But through the CRD, the API server is able to get this custom resource and store in etcd. But nothing is still happening, right? Because the controller manager on the other side has the controllers running, but they understand what the deployment is, what the replica set is, not what this complex app kind is. This is where the second part of the operator pattern comes into the picture, which is the actual operator. So instead of having a human operator, you have yet another containerized application. So you are putting the business knowledge about your complex application within an operator. So as the human operator knows how to deploy this database, how to deploy this messaging system on Kubernetes, I need this, this, and this, you are just writing an operator as a developer, and you are putting this logic inside this containerized application. So the operator will work the same way as we saw in the controller manager. So it's made by one or more controllers. It depends on how many custom resources, because you can extend the API server even with not just one kind, with a new kind in Kubernetes, but adding more custom resources. So all these controllers will go just the well-known reconcile loop. So observing, so watching if a new custom resource was created or it was updated. Analyze, getting some other information about that, and then acting with the create and patch. But what is going to happen on the other side? It means that the operator is going to create for you all the YAMLs, all the Kubernetes built-in resources this time, that are needed in order to run your complex application. So the operator, which has the business knowledge about that, it's going to create the pods or the all needed config maps that it needs, the secret, the PVCs for the storage, and so on. But of course, not just deploying. It will happen even in case you want to upgrade your application. So you have just to change everything in your single custom resource. You don't have to change these built-in Kubernetes resources created by the operator, which are called operands. They are owned by the operator itself, and they are strictly related to the custom resource. It means that if the user is going to change something on the operands, the operator going to the reconcile loop will just revert back all changes, because the only source of truth is always the custom resource. So from a developer perspective, you have to define the CRD, the logic in the operator. From a user perspective, the user has just to deal with one or a few custom resources to deploy the application, but not dealing with all the other stuff that is needed in Kubernetes in order to run the application itself. But so in general, an operator, so after creating all this stuff, we need this stuff running, right? So this is where the controller manager kicks in, because in the end, it's creating pods, config map secrets, so all the other controllers that are in charge of handling this Kubernetes resource will just run the application for you. This is not the only way to use an operator, so it's not just about running something on Kubernetes. Let's think about having an external service, for example. So in a so-called hybrid cloud environment, you have your complex application made by some microservices running within Kubernetes, but you also need some cloud services, so which is outside of Kubernetes itself. let's take, for example, I don't know, you want to use an Azure Service Bus, okay, which is a messaging system provided by Azure in the cloud, so by Microsoft Azure in the cloud. So you can decide that your Kubernetes cluster is your kind of control plane, so the single place where you want to deploy and manage your application. So you can use, for example, Microsoft provide an Azure operator where you can provide a custom resource which describes your service bus instance. So you create your service bus instance as a new kind in Kubernetes, and the operator will talk not with Kubernetes itself in order to create some YAMLs, but talking with the Azure cloud to create this service bus instance out, right? Or, yeah, at the same time, then running, for example, your application using the service bus. So there are different ways that an operator can be used, not just running application on Kubernetes. So let's take an example, how it works in reality. What if I want to deploy something like Apache Kafka on Kubernetes? For people who don't know, so Apache Kafka was born as a publish-subscribe messaging system, but today is well known as a data event streaming platform. So you have this cluster shape. So an Apache Kafka cluster is made by different nodes, the brokers, and we have the controllers working in craft mode. It's storing the messages in topics, and clients connect to the brokers and start to exchange messages between these topics. But Kafka comes with its own complexity. It's not that simple to deploy an Apache Kafka cluster. In order to configure each node in your cluster, when you have to do some configuration change, for example, so you have to change a configuration on a broker, you have to roll the broker, and then after rolling the broker, you can move on and upgrade the next broker, and so on. If you want high availability, so you want the client still connected to the cluster, still be able to use the brokers, so in order to exchange the messages through the topics. And that's the same if you want to upgrade the Kafka version. So you have to do that for each brokers. Also, secure the brokers is not that simple. You have to your TLS certificates, you have to configure all the brokers for the TLS certificates. You have to generate these certificates to be used and so on. So you can do that maybe on Kubernetes, just creating a bunch of stateful set in this case, because Kafka is anyway a stateful application, and then you need a bunch of config maps for configuration on the brokers, secrets for the TLS certificates, the PVCs for the storage. But what if we go the way of having an operator for that? So it's a matter of having a custom resource definition, creating a new kind Kafka, so making Kafka a first-class citizen in the API server, so that you can describe in the spec what are the information about your Kafka cluster. And then, yeah, you are extending the API server through a new endpoints where you can get your Kafka assistance, and you can see using the kubectl command, you can just go and get kubectl get Kafka instead of get a deployment, a pod, or something else. So a user can create, here on the right-hand side, you can see a Kafka custom resource where there is nothing about Kubernetes built-in resources, right? You are specifying the version of Kafka, how many brokers you want through the replicas field, the listeners for exposing the Kafka cluster to the clients, the configuration that you want on the nodes, the storage that you are going to use, and then the operator can take care of this custom resource, can spin up everything needed for running Kafka, and then it's going to update the status so that you know what's the status of the cluster, it's ready, there are some issues, warnings, or so it can also provide the TLS certificates, the public CA that you have to use in order to connect to the brokers from the clients using TLS and so on. This operator already exists, of course, and it's called Strimzi. So Strimzi is an open source project. It's part of CNCF, so as an incubating project. It focuses on running Kafka on Kubernetes. It provides the container images using the Kafka upstream community binaries, of course, but also it's based on the operator pattern. So it provides not just one operator for running and deploying Kafka, but some other operators in order even to handle topics and users within your Kafka cluster. So these are some of the custom resources that Strimzi provides. So as you can see here, you have a Kafka custom resource together with the Kafka node pool that you create in order to ask the Strimzi operator to deploy your cluster. There is also Kafka topic and Kafka user that you can use in order to describe, I want to create this topic with these partitions or replication factor with this configuration. The same for the Kafka user in order to have the ACLs for the clients to connect to the Kafka cluster. And Strimzi will set up everything for you. So it's going to create all the pods, the config map for configuring the brokers, the secrets for the TLS certificates, the PVC for the storage, and the network policy to be sure that only specific application can connect to the nodes within the cluster. But it's even more. You have got also, because the Kafka ecosystem is not just Kafka, it's not just the brokers. There is also Kafka Connect for moving data between different systems across Kafka. You have Kafka Mirror Maker for mirroring Kafka cluster. There is also a resource for having an HTTP bridge in order to connect to the Kafka cluster using the HTTP protocol. And even in this case, it will be about creating Kubernetes resource for running Mirror Maker, for running Connect, for running your HTTP bridge, which is a containerized application. But as I mentioned before, the operator can even do something different that communicating just with Kubernetes. The last two resources here, the Kafka Connector and Kafka Rebalance, are about using, for example, Kafka Connect. So in Kafka Connect, you can have several Kafka connectors for moving data across different systems. You can configure your Kafka connector by using a specific custom resource, and the operator is going not to do something in Kubernetes, but talking with the Kafka Connect API. And the same with this Kafka Rebalance custom resource, because there is an integration with Cruise Control. Cruise Control is an open source project by LinkedIn, which is used for rebalancing your Kafka cluster when you have some broker getting more load than the others. So it's not balanced. You can just create your Kafka Rebalance custom resource, defining some goals, and the operator talking with the Cruise Control API will get the so-called optimization proposal and running and asking Cruise Control to running the rebalancing for you and getting also the status. So the operator is doing what a human operator was going to do, right? But it's everything happening for you. So let's see how it really works. So I have here my Kubernetes cluster. There is nothing running. And just to make sure that Kubernetes does know nothing about Kafka, if I do something like that, right, kubectl get Kafka, it's just saying, I don't know what the type Kafka is. So for this reason, I am going to install, first of all, the operator. So this is a really simple way where you can start with Strimzi. It's going to install the CRDs and the operator deployment in this Kafka namespace. So after creating this, while the operator is now starting up, if I ask the same question to Kubernetes, we'll see that the answer is different, right? So it's going to say, I cannot find any resource. In this case, in the default namespace, let me add the right namespace that I'm going to use, but it will be the same. Because, so the difference with the previous answer was that before that, we didn't have the CRDs. So the API server was actually not aware of something like Kafka. Now it's aware about Kafka, but there is no Kafka on the cluster. So the operator is now running. At this point, let me create a Kafka custom resource. So this is one of the YAML coming from the example in Strimzi. While it's going to create the Kafka custom resource, and we'll see the operator at some point will spin up the brokers and the controllers. Let's take a look at the Kafka custom resources. I already mentioned before. So now if I can get my Kafka, it's called my cluster in the Kafka namespace. And if I want the YAML, you can see here a kind of an example of a simple example of the Kafka cluster. So you, as a user, you are not dealing with all the stuff around pods and config maps and so on. You can configure your Kafka cluster, use this config section. You can configure the listeners, which are used in Kafka in order to expose, the brokers to the clients. You are specifying the Kafka version. And you see the operator, and the operator is also deploying these other two operators, the topic and the user operator for handling topics and users. And you can see that now the operator is reporting back. So it's dealing with this Kafka custom resource. And is reporting back, OK, I am creating this cluster. It's not ready yet. I will back to you. But what's doing underneath? We can go and see, for example, that right now, we have in the Kafka namespace some pods running, right? They are still not ready. But, for example, we have all the different config maps, which are hosting the configuration for the brokers. Or we are getting the services in order to connect to the Kafka cluster. At the same time, you are getting the PVCs, which are used in order to binding to some storage for storing the messages. So the operator knows the logic, knows how to deploy a Kafka cluster, how to manage a Kafka cluster, and it's creating everything for you. So let's back and see if everything is up and running. So the brokers are running, the controllers are running. I'm running Kafka. For people who know about Kafka, it's moving away from using Zookeeper for storing the cluster metadata. It's using Kafka itself. So there are some nodes named controller. It's everything up and running. So if I ask again about the Kafka custom resource, you can see now that the status is ready, and it's providing you information about the listener, the CA public certificate for connecting to the cluster, and so on. This is the day one operation, right? Just deploying the cluster. But what if I want to edit something? And as I said, it's not that simple in general. So I go on my Kafka custom resource. I can edit. Let's say I can scale up, for example, increasing the number of replicas. Or for example, I can update some parameter. Let me add some retention parameter to the Kafka instance. When I'm going to update the Kafka custom resource, the operator will take care of the change and will do what's needed. So it's going to rolling the broker one by one for us. So I updated my custom resource, and the first broker is rolling. So as you can see, it's the operator taking care of everything, right? When the broker will be ready, and when all the partitions are in sync so that there is high availability, there are no partition offline, and you can use your Kafka cluster still while upgrading the cluster itself, the operator will move to the next broker. So the broker 5 is finished, and then it will move to the next one and rolling up to the end all the brokers within the cluster. Yeah, so the next one is rolling. The same would apply to any kind of change that you can do on a Kafka cluster in terms of Kafka custom resource. So back to the presentation.
OK, so we've given you a bit of an idea of how a Kubernetes operator works. But it might be you've seen lots of different tools that manage Kubernetes deployments and pods and things like that. So how is it different from the alternatives? There are plenty of alternatives. So alongside the operator pattern, you can do things like Helm, Ansible, Customize. Today, we're just going to talk about Helm. And the reason for that is it's a really good way to solidify what the difference is between these kind of tools and an operator. So hopefully, that'll reinforce what we've already showed you, but also help you to, in future, look at other tools and determine what is that giving me versus an operator. So what is Helm? Helm is an open source project. It's Apache 2 licensed, and it provides a package manager for Kubernetes. It's a CNCF graduated project, and the basic aim behind it is to make it much easier for you to deploy complex applications, like, for example, Kafka. So what is the difference? Well, in Helm, it relies on the Kubernetes built-in resources. If you take a Helm chart, it is basically made up of lots of different YAML files that represent all of the deployments, the config maps, the services, the PVCs, etc. that you need. This means that you have all of those files that you have to manage. If you go the operator route, then because we're extending the Kubernetes API with that CRD, you don't have to manage all of those different resources. So in Helm, the way they get around this to make it simpler is through customization. So you have all of these YAML files, but actually, in reality, you just change 1 or 2 files that have the specific configuration. And the Helm tool will basically make sure that whatever configuration you set, it distributes that in the different YAML files. So it updates all the YAMLs to have the right configurations, so the right number of pods or whatever, to then apply it. Whereas, of course, in the operator pattern, the thing you're managing is those 1 or a few custom resources. So at this point, they're looking kind of similar. We've got a lot of YAML files for Helm, but actually, you don't have to necessarily do anything with them. You've just got those couple of templating files for Helm and then the couple of resources for operators. But the key thing really is the day 1 versus day 2 operations. So in Helm, it's ideal for day 1, for deploying your complex application. It makes it really easy for you to specify those pieces, and then off you go. But because it doesn't have that controller part, it doesn't have something that's consistently running and watching your application, it can't do the day 2 operations. That's those day 2 operations around what happens if I make a change. I don't just want to do, for example, in Kafka, a rolling update. I want to update the pod and then be calling the endpoints to check, is everything now distributed? Are all of my topics up and running again before I move on to the next one? So that's where operators sit apart from some of the other kinds of tools you will have seen, is that it lets you do those day 2 operations. And we really think that's the power behind an operator, is it's that constant monitoring that otherwise a human operator would have to be doing. And as a bonus insight, you can actually deploy an operator via a Helm chart. So when we deployed the operator, you saw there was quite a lot of lines that came out because we've got all the different CRDs. We have to provide permissions for the operator to be able to use those resources, and then there's the actual deployment itself. So Strimzi, for example, provides a Helm chart to deploy the actual operator. OK, so hopefully we've convinced you that operators are cool and interesting and something you should be considering. But where do you even start with this? So the first place to look definitely is the operator framework. It's another open source project, and it provides a toolkit for managing Kubernetes operators. So there are 3 parts that you can look at that are really useful. So the first is for building an operator. So it provides an operator SDK, so you can build your own operator using Go. And this basically takes away a lot of the additional logic you would have to think about. So without the operator SDK, you would have to write all of the code to actually interact with the API server, to create the watches to see, has something changed, determine, OK, this has changed, now I need to update this resource, and then again implementing the request to do the patch, to do the create, and all of that. The operator SDK basically sort of takes that away from you, so you don't have to worry about that. You can just focus on, if somebody has asked for 3 replicas in Kafka, what does that mean? Does that mean I create a certain number of pods or whatever? So it lets you really focus on that business logic, which is the real best thing about having an operator. So the second one is managing. So this is the operator lifecycle manager. When you're running an operator, there are additional management pieces because you have this constantly running application that you have to manage. So if you want to adopt a new version of the operator, you obviously have to move to the next version and update that. But you also need to understand what versions your operands are, so what version of Kafka you're running, and moving those forwards. So the operator lifecycle manager basically helps with all of that. And then finally, under Discover, we have Operator Hub. So Operator Hub is a place for you to go to discover existing operators. So it might be that you aren't interested in writing your own operator, but you want to see if there's some out there already. So this is a great place to check out and see all the different kinds of operators for existing complex applications. And of course, if you look here, then you will find Strimzi. So the other thing we want to talk about actually is the Java operator SDK. So this is separate from the operator SDK that I talked about a minute ago. And this one is specifically for if you want to write Java-based operators. In Strimzi, the main cluster operator is actually not using this. And the reason for that is because Strimzi's been around for a while, and we started writing it before this existed. So this would have made our lives a lot easier if we'd have used this. So in Strimzi, if you have a look at the code, you'll see we have all of that complex logic of interacting with the API server. But for some of the new operators that we've added within the Strimzi project, we're now making use of this. So this is an open source project, and it provides that framework for writing Java-based operators. So it's a similar thing. You don't have to worry about all the watching and everything. You just focus on the business logic. And it's built on top of the Fabricate client. So for those of you who are familiar with interacting with the Kubernetes API, Fabricate is a great way to, in Java, talk to the Kubernetes API server. And that's what we're using in Strimzi as well, actually. So hopefully this has given you an insight into how an operator works and why you should really consider one, and then a place to go and look for some. Definitely check out Strimzi if you're interested. And then we've just put a link here for if you are interested in Kafka more generally to see more information. And the final thing I just wanted to note is, for those of you here in person, I mentioned that I'm an author, so I've written a book about Kafka Connect, and I'm going to be doing a signing, so you get a free book signed straight after this over by the sticker table, so if you're interested. But other than that, thank you very much.